Okay, like what I'm saying, so we're talking about redundancy in a lot of chapters already. So we've been talking about um, the hierarchical model design and that we need to implement redundancy to avoid yung single point of failure. And talking about that is really something na parang napakadali. Napakadali para sa atin pero sabihin pero it's really something else. There will be problem of course if you do or if you create multiple connection from different devices. Problems may occur. Okay, but fortunately there's already a solution to those problems. So, wala tayong poproblemahin. So the main problem here is actually the layer 2 loops. So those are the issues. We have three issues in the layer 2 loops. By the way, the coverage of the redundancy I'm talking about is up to the layer 2 redundancy only. So medyo switches lang ang pinag-uusapan natin dito. Later pag-uusapan din natin the redundancy in the upper layer pero for now let's focus on the switches. So from the diagram alone, you can see that uh, there's already redundancy here. Kung tutuusin kasi, you can remove this connection here, link, or you can remove this link, or you can remove this link. Either sa mga yan pwede mong tanggalin. They're all still connected. Kaya lang kung mapapansin nyo, these three switches are connected to each other in a mesh topology. Full mesh nga in dating niya, di ba? Kasi connected siya, si S3 connected kay S1, S3 to S2, S2 to S1, etc. Okay? Now, what am I talking about a while ago when I talk about issues? So actually, there are three issues there. So one is mock database instability. So meaning to yung registry ng ating database, mock table. So nagkakaroon ng or pabago-bago. Nag-iiba-iba yung entry. Dati, sasabihin niya, ang way para pumunta kay S2 from i-record kay table ni S3, i-record yung yung trunk 2. Yan, trunk 2. This trunk 2 is the only way for you to go to S2. Yun yung i-record kay S3 pag nagparamdam na yung PC1. Kaya lang later on, mag-update si S1, sasabihin din niya there's a way here to go to S2 and that is through the trunk tree. Dadaan ka sa akin. Then pag may na-receive na naman na update si si S2, then ganun din na naman. So that is a big problem. Hindi mo ngayon basta-basta ma-reach yung destination relying on the MAC table because it's not stable kasi nagbabago-bago. Another is broadcast storm. You know, all know the load of broadcast when you send a broadcast here, switch 2 will send the broadcast to all ports except from the origin. Pagka na-receive ngayon dito, magkakaroon na naman ng broadcast dito. Pag na-receive dito, magkakaroon na naman ng broadcast dito. Pag na-receive niya yung broadcast nito, ibabato na naman niya dito. Babato doon. So bumabalik up to the point na congested na yung network nyo. And then multiple frame transmission, dumaan yung broadcast yun. Dumaan dito, pumunta doon, dumaan dito, pumunta doon. Eventually, dalawa yung natanggap nitong computer na to. Okay? So to be more specific, I think we have here a specific slide for every issue, I think. Let's check. So it's there already, like what I've mentioned. So parehas na parehas yan. So PC1 sends broadcast frame to to S2. So syempre nung nakita siya ni S2, then ibo-broadcast niya papunta kay switch 1, switch 3, sa lahat ng port, pupunta din kay 10.23, papunta kay 10.22. Okay? Now, with regards to that, syempre, mag-a-update ng database. Sabi nga dito, S2 updates MAC table for PC1's MAC address on port 11. So, ayan. So, para ma-reach daw si PC1, yung ganitong MAC address niya, i-register na kay S2 na yung MAC address niya reachable through port 11 of this S2. Okay? Ngayon, yung ano na yon, yung frame i-forward na sa lahat ng yan. Pag na-receive ngayon ni S3 yung frame na galing kay PC1, malalaman ngayon or i-register din niya ni S3 sa MAC table niya na PC1 is reachable via trunk 2, okay, via trunk 2 or yung port na F02. Okay, so okay lang yon kasi nga, totoo naman, reachable yan. There. Trunk 2 or F2 ang gagamitin. Okay, F02 ang gagamitin ni S3 para ma-reach mo si PC1. PC1, F02. Ayan, naka-note na lang doon. Kaya lang, tingnan natin ha. Siyempre, broadcast yan. Nagpunta doon. Nag-broadcast din dito. Nag-broadcast din doon. Nag-broadcast din ngayon doon. So, ngayon, anong mare-register kay S1? So, si S1 will also create an entry in its MAC table that PC1 is also reachable via F01 of S1. Via F01. So, pupunta daw doon. What's the tool of broadcast? Natanggap niya, papadala niya dito. Kakaroon ng broadcast, papadala rin niya dito. So, once na naipadala ngayon, after sending the frame to S3, S3 will receive the frame from PC1 again. Again, okay? So, anong mangyayari? S3 will register into its MAC table that PC1 is reachable via F01. Kanina F02, ngayon F01. And then pagka-broadcast niya, papadala niya dito, si S1 will also register another entry, an entry into its MAC table that PC1 is reachable via F02. Na-imagine nyo ba? That's something na magiging problema nyo because the MAC table is not stable. Table not stable. Okay. It's what they refer to as MAC database instability. Okay, yung MDI natin. So that is a big problem. Actually, loop ang mangyayari dyan continuous loop. Kasi nga, swertihan na lang kung nakuha niya ng tama. Pero it will change almost instantly na sa dami ng frames na umiikot, circulating inside the network, then your database MAC database is actually not behaving regularly, meaning nagbabago-bago siya. It's not stable. Okay, so that is the MAC table issue. Aside from that, dun pa lang kanina, after seeing how broadcast works, so once PC1 broadcasts or sends a broadcast to S2, S2 will send it to other ports, and then S3 will broadcast to here, papunta kay S1. Then S1 will broadcast to S3. Pag na-receive ni S3, babato na naman niya dito until nagre-recreate yung frames, dumadami ng dumadami, and your network is already congested. It happened before personally actually in CCS. We have a technician before. Hindi ko na lang sasabihin kung sino. But I am the network administrator before, and ako yung nagbi-maintain sa control room. Then, yes yata, si Sir Edgy, hindi, after ko si Sir Edgy yung pumalit na network administrator. So, I was monitoring yung nangyayari dati. Then, bigla na lang na-disconnect ang buong CCS. So, I went immediately doon sa control room. I asked the technicians, ano nangyari, etc. etc. Wala naman daw silang ginagalaw. So, I don't know what's happening. Actually, naka-up yung mga switch. Kitang-kita naman. Naka-on lahat. Then, I check one by one. May nakita akong may isang cable na kumbaga hindi familiar sa akin. Alam ko kasi nga ako nga yung nagmamap dun. Hindi siya familiar sa akin. So I asked, so sino naglagay dito? Sabi nung technician natin noon, siya daw. So that's the cause actually, sabi ko kasi connected na yung dalawang switch na yan. So kinonect mo pa uli sila, that's redundancy. So okay lang yan kung Cisco switches ang gamit natin for our backbone. But we are using a um, fixed configuration switch. So kung doble yan, magkakaroon ng broadcast automatic ano yun, recreation ng mga frames kasi nga dumadami nagkakaroon ng broadcast. So eventually mapupuno yung ano mo, yung switches mo. Tapos madi-disconnect ka. So paano mo masusolusyonan yun? Patayin mo lahat ng switches. Kukonect ka. Pero later on, makukongest na naman sila. Ilang segundo lang yun. Wala ka na namang connection. So what I did was to remove yung switch na yun, yung extra cable. So pwede sanang dalawang cable na yun kung may Ether channel lang noon, kung naka-Cisco switch lang. You just need to configure Ether channel dun sa dalawang kable, okay na. Kaso hindi eh. Fixed configuration yung mga switch doon. So that is the broadcast storm. And lastly, we have the unicast, duplicate unicast. Nasabi ko naman na kanina. So pag si PC1 nagpadala kay S2, then S2 will broadcast, yan. Then S2 will go send it to S3, and then S3 will send it to S1. S2 also send the same frame. So dalawa ngayon yung matatanggap okay, uh, ni S1. Sorry, it's not broadcast, it's unicast. Nakalimutan ko. Merong entry kasi to papunta kay S1, meron din entry si S3 papunta uh, kay S1 or rather kay PC4. Kagaya nung nangyari kanina, papunta kay PC1, may entry kay S2, may entry kay S3. So kung sinunod niyo lahat yon, magkakaroon ng duplication. So, yun yung common problem natin na na-encounter when we are referring to the duplicate unicast frames. So, sabi nga dito, an unknown unicast frame is when the switch does not have the destination MAC address in its MAC address table and has to broadcast the frame all out of all port except for the port the frame was received on. So, first una broadcast, syempre dahil nga binodcast mo, magkakaroon siya ng entry binodcast. Kagaya ng in-explain ko kanina sa inyo, dun sa first issue natin sa MAC table. Then magkakaroon ng entry dito, broadcast, tapos eventually makakarating kay S1. Then, there you go. Marireceive lahat ni PC4, kaya lang duplicated na. So, that will cause of course yung kumbaga parang dinodoble-doble mo, paulit-ulit na lang yung pinapadala mong frame kay PC4, which is not necessary as it will cause a lot of delays and problems in the network itself. Okay. So how to solve that? Okay, how to solve that? So the solution actually is very easy. You do nothing. You do nothing. Why? Kasi nga, by default, yung mga Cisco switches natin, meron ng STP. Actually, maraming variation ng STP. Pero mamaya natin pag-usapan. And I'm not aware or familiar with other non-Cisco switches kung meron din sila. Pero we're talking about Cisco switches here. So, talking about Cisco switches, naka-on na siya by default. Although pwede mong pakialaman yung election later on. Uh, that is possible kapag naglagay ka ng konting configuration like babaguhin mo yung priority or yung bridge ID. Okay? So if you adjust the priority, then mababago nga naman. Ano ba yung tinutukoy kong priority? Later on, pupuntahan natin isa-isa yon. So sabi nga dito, the STP creates one logical path through the switch network. One logical path. Sir, paano yon? Remember, for example, ito yung network nyo. Ang daming, there are two ways to go to reach PC4. If you are from PC1 going to PC4, there are two ways, di ba? You can pass through S2 going to S1 papunta kay PC4 or S2 going to S3 going to S1 papunta kay PC4. So in that case, tatanggalin mo yung isa. So in this scenario, looking at the flow of the traffic, obviously ito naman ang tatanggalin natin. Kaya lang merong ano yan, merong um, basehan yan. They are computing all of the values or comparing, should I say comparing yung mga values to determine kung sino yung magiging root bridge natin, yung mga, saan yung mga root ports, designated ports, etc. Alternate port. Mamaya pag-uusapan natin yon. So, the bridge protocol data units will be utilized by the STP. Okay? Siya yung magsesend nun. Tapos pagka nakita na niya ngayon, nakapag-compare na siya from different values. For example, S2 will send BPDU to S1 and S3. S2 and S3 will compare. Tapos pag na-compare na niya, ano yun, mamaya sasabihin ko kung ano yung kinukompare. Then, yun yung magiging bago. Tapos, magko-compare din si S1 and S2. Then, hanggang sa makuha nila kung sino ba yung uh, magiging or mananalo. Actually, there's an election. It's a sort of election. Not really election that switches elect, but election that uh, the policy or the computation, the algorithm computes para makita kung sino yung um, mananalo. So, in this case, what happened here is, ayan, andito naman. So, SDP send BPDU between layer 2 devices in order to create one logical path. So, a port on S2 is blocked so traffic can only flow one way between two devices. Gaya ng sabi ko kanina, actually nasabi ko naman na lahat. So when trunk 1 fails, just in case ito yung natanggal, what if nasira to? Sir, what if nasira to? Or what if nasira din to, hindi na ako makakonect doon? So this will activate automatically. Hindi mo naman siya disconnect. So it was set to blocking port because of the computation. But once there is a problem with the links and you can reach one point of the network because of that problem, then the blocking port will be activated. Okay? So paano ba nangyayari lahat? So let us be familiar first with some terminologies. Okay, meron kanina na-mention ko na yung root bridge and the root port, designated port, alternate port. Nasabi ko na yan. So now, ayan, makinig daw muna tayo sa sounds. Okay. So, thank you for the intermission. Let's look at the different port roles. We have the root bridge. So, aside from the root bridge, we also have the root port, the designated port, the alternate port, and the backup port. So, what is the root bridge? It is winner of from the computation. So yun yung sinasabi ko kanina sa inyo. It has okay, hindi ko muna sasabihin yung computation, but it is the only device, sabi nga nila, in the switch network that will be considered as the reference from uh, to the computation of the different other roles. Okay? Kasi yun yung device siya na magiging reference point natin. For example, in this diagram, it shows that the root bridge is S1. And because the root bridge is S1, we can easily determine the designated port, the root port first, and then the designated port, and then the alternate port. So there will be cases like this, and you will be comparing again for you to determine which of these two ports will be the alternate and the designated. Kasi pwedeng ito yung alternate, pwedeng yun yung designated. It really depends. Okay, meron tayong basihan mamaya. So the root port, okay, it's one port on a switch that has the lowest cost to reach the root bridge. So sabi ko naman sa inyo, root bridge is the basis of the computation. So in this switch, what port will have the lowest cost to reach S1 from S2? Definitely yung kung ano yung directly nakakonect sa kanya, di ba? So F01, okay, is directly connected to S1. It is the lowest cost kapag gusto mong padaanin dito yung frame mo, then that will be assigned as the root port. Ganun din kay S2, S3, sorry. The nearest port to the root bridge is F01. So that port will be assigned as the root port. Malinaw ba yon? So root port, yung pinakamalapit sa root bridge. So yun yung basehan natin is the root bridge. Now, the designated port, sabi nga dito, take note one root port per switch. The designated port, sabi dito, is selected on a per segment basis. Okay, so every link. So, based on the cost to get back to the root bridge, okay, to for either side of the link. So, kumbaga parang titingnan mo yung side yung dalawang side ng ito yung reference, the root bridge. If you're looking at S2 on this side, okay, kasi nga meron tayong loop na ganyan. On this side, ano yung pinakamalapit na port para mapunta ka kay root bridge? Definitely yung mismong port ni root bridge. So automatic 'yon. Okay, kasi hindi mo na pwedeng gamitin din 'to. Hindi mo pwedeng gamitin 'to dahil nga root port na yung mga 'yan. So yung adjacent side niya, automatically nagiging designated port 'yon. So ito na ngayon sa kay S1, si F01 saka si F02 are the designated ports. Now the question is, on this side of S2 and this side of S3, paano naman yung magiging designated port? Sino yung magiging designated port? Actually, both of them are candidates for becoming a designated port. Okay? Kaya lang hindi mo pwedeng sabihin na designated port silang dalawa because one will be considered as the alternate port or blocking port sa RSTP kasi alternate port. So, let's look at the definition of the alternate port. Backup port for the designated port when the other side is not a root port. Mamaya, merong slide na specific. There's a slide specific to this discussion on how we are going to compute the alternate or designated port. Actually, it's more on comparison. The lowest is the winner. So mamaya pag-usapan natin later. And then we also have the other role, the backup port, RSTP again. Backup port for the root port. So, hindi muna natin pupuntahan yan. Let's go to the more specific discussion now. So, how to become the root bridge? Okay, balikan natin yung diagram kanina. Ito yung root bridge. So, how to become a root bridge? So, it's very simple. Look at the bridge ID. Okay? So, ganun lang kadali. Panalo ka na. So, if you have the lowest bridge ID, you are the root bridge. Okay? You are the root bridge already. So, ang mangyayari, for example, in this diagram, BPD will be sent to S1 and S2, comparing or checking. Siyempre, matatanggap ni S1 ang ang bridge ID or priority ID is lower. Okay? Lower yung pinadala sa akin, hindi ko siya papansinin. Hindi ko siya i-ignore ko siya. I'll ignore the BPDU from S2 because I have a lower priority. And then S2 will also send BPDU to S3, and then we'll compare. Okay? Same, they have the same priority value. So who will be anong mangyayari? I-ignore ba nito? No, because kung parehas sila ng priority ID 32769, 32769, the next the next point of comparison will be MAC address. Sabi nga dito, if bridge priority is not changed, like this is the default default, the MAC address will becomes the determinant for the root bridge. So in this case, lower yung MAC address ni S2. So ngayon, ang gagamitin ngayon, BPDU nito, ipapadala niyang BPDU, hindi yung sa kanya. Ang ipapadala niya, actually, it's on the priority but it will be sent here, kaya lang, I was supposed to tell you na babaguhin yung priority, kaya lang hindi nga parehas nga pala sila. So, basically, i-recognize ni S3 na mas mababa yung MAC address nito. And continue, papadala pa rin niya yung BPDU niya kay S1. But S1 will also ignore kasi nga mas mababa sa kanya. Now, ito yung mangyayari. S1 will also send, of course, hindi pwedeng it's not just S2 and S3 that will send the BPDU. S1 will send the priority ID, and then malalaman ni S2, siya yung root bridge for me. Currently siya yung root bridge. Kasi by default, when a switch turns on, it will assume that it is the root bridge. So medyo ma-feeling sila. So once na nag-turn on sila na yung root bridge. So after comparing, dun pa lang niya malalaman. After comparing, then after receiving updates or BPDU updates from S1, S2 will be informed that S1 has lower priority and that S1 is the root bridge. Ganun din ngayon si S3. It will receive updates from BPDU updates from S1. Then it will see that the priority is 24577. So once S3 sends an update to S3, parang ginagamit na niya is the 2455772 na 24557 na priority. Okay, para malaman din ni S2 na yun yung priority na pinag-uusapan natin. And that is the priority value of S1. So S1 will win the comparison, and then S1 will become the root bridge. But anyway, but kung nga ba di-discuss dito, I think there's a separate slide for that later on. Pero at least I've already discuss the process. So the basis originally BID has two fields, sabi nga dito. Ayun, priority and MAC address. So priority first, if it's not changed, this can change, sabi dito. So meaning you can configure this. So yun yung sinasabi ko kanina. Yan lang ang configure nyo. So you can configure this if you want S3 to become the root ID, root bridge, kasi alam mo yung network, you know the network, you know that this is the most strategic area to become the root bridge, then modify the priority. Then later on, it will win automatically as the root bridge. Okay, so basis is priority, and if it's not changed, it's in the default. Uh, the basis will become the MAC address. Okay, so next, um, the root path cost. Okay, so root path cost is used to determine the role of the port and whether or not traffic is blocked. So yun na naman. As I've mentioned a while ago, the basis of being the root port is of course yung ito, lowest cost to reach the root bridge. So lowest cost to reach the root bridge. So basically kasi without any changes, ito yung ano natin. Ito yung directly connected na makikita natin. But what if there are multiple, di ba? If there are two ports connecting, then you can also decide there. So what will be the basis? So there is a command for every interface. Take note, it's inside the interface. If you want to set the cost, for example, of S2's FA01, this one, if you want to adjust the cost, then you just issue the command spanning tree cost. Then specify a cost, 25 in that case, di ba? So there is a basis here. Usually by default, you can check the costing here. Okay? Para lang alam ninyo. So if you're, the lower the better, ah. Okay. So, after modifying, then definitely everything will adjust. Okay. So now, like what I've mentioned before, uh, if the basis of our topology is like this, being S1 as the root bridge, then the root port will automatically be F01 of S2 and F01 of S3. So yun yung agad na nakikita nating root port. Okay? And the designated port is yung directly connected. Okay? Directly connected, designated na yan. Now, every end, sabi natin kanina, it's in every end. So, kung meron dito sa end na to, meron din dito sa end na to, sa side na to. Meron ding designated ports dito dapat. Kaya lang hindi mo na yan sinabi kasi ito lang muna yung pinakamadaling ma-determine. So, the nearest port to reach the root bridge from S3 will become the root port. From S2, that will also become the root port. Okay? And then, from our definition a while ago, sabi natin, the designated port is selected on a per segment basis based on the cost to get back. Okay, get back to root bridge for either side of the link. So we're talking about links here. So in this case, ito yung link na to get back to S1, it's the only remaining port, which is the F01 of S1 and F02 of S1. Okay, the directly connected ports. So yun sila. Ito, F02 and F01 of S1. Now, hindi pa tapos. So to get more of the roles, etong question dito, sabi nga yan, naka-yellow. So which port is the designated port? So which switch, S3 or S2 has the lowest BID? So yun pala yun. Okay? So if you are confused on who will become the designated port in this link, is it F02 or F02, F02 of S3 or F02 of S2? It is based from the lowest bridge ID. So there's a bridge ID. In this case, bridge ID of FA01 or rather FA02 is ayan 32 769.00 A002222. Okay? Now, the F02 here is on the other hand the same yung 32769 pero 11111 lang siya. Okay? So, who's the lowest? Ito yung lowest. So, ito ngayon yung magiging, siya yung mananalo, ito yung magiging um, designated port. So, F02 of S2 will become the designated port. And on the other hand, the F02 of S3 will also supposed to be a candidate, di ba? Candidate for as designated port, kaya lang hindi siya nanalo. So, siya yung magiging alternate port. So, alternate port siya noon. Ito yung designated, ito yung alternate port. Okay, so in this case, there's another one here. So, root bridge, so automatic root port. Tapos, para makalapit dito, ito yung pinakamadali, root port. Assuming this is the winner, So, ito naman kasi pinakamadaling bumalik doon. So, this will be the root port. And automatically, the adjacent side are designated port. Adjacent of this root port is designated port. Adjacent of this port is the designated port here. Ang question na lang, who will be the designated port here? Okay? So, again, if comparison, based on comparison, the winner is F02, siguro naman dahil siya yung pinakamalapit, then that will be the designated port. And this will be the alternate port. So alternate port is somewhat like a block port na hindi ginagamit, deactivated, pero connected. Okay? Hindi lang siya ginagamit because just to prevent loops. But if in any case, something happened here, for example, sa trunk 4 got disconnected, then it will automatically activate. Okay? Everybody will know that this is disconnected. So, F02 of S2 will activate. So, yun yung backup plan. So, basically, STP removes this kind of problem or remove this kind of redundancy virtually, logically, just to prevent loops. But physically, it's still connected. So it will activate once there's a problem from the other links or existing links. So any questions? Wala. So here, don't worry, I'm currently recording the video or my discussion, again, a raw discussion for you to have something to go back to later on. So here are the different BPDU frame formats. So makikita nyo protocol ID, version, message type, flags, root ID, root path cost, bridge ID, port ID, message age, max age, hello time, forward delay. So things like that. Okay? Just for you to have a reference. Later on, you will be using them for computation, especially yung mga root ID natin sa bridge ID. So, again, the process I already mentioned a while ago. Diniscuss ko na sa inyo to. So, there will be a comparison between S2 and S3. Okay? So, S3 is the winner. S2 is the winner because the root ID is 001, 111 compared to the bridge ID, the root ID. The bridge ID of this one. Okay? Bridge ID is 2222. Bridge ID is 1111. Pares lang sila ng 3279, 69. So, ang gagamiting root ID ngayon, which is the reference or yung ina-acknowledge nilang root bridge winner, is 1111. So, S3 will now change its root ID to 1111 to acknowledge that S2's bridge ID as the winner. But after seeing, ayan, dito pala sa next. So S2 will also send BPDU update to S1 here. But the thing is, the bridge ID of S2 is lower. So S2 will not change the root ID. It will just ignore the message from S2. And then after that, here, step 3, S1 will send um, a BPDU to, saan nga ba? Uh, we are into step 3 already. So S1 will send a BPDU to S2, but of course the root ID, after comparing that, uh, the lower value after na-receive niya yung message from S2 kanina, inignore niya yung 1111, yung 32769, that 000A00111, basically the bridge ID was ignored because S1's bridge ID is lower. So gagamitin niyang root ID niya is yung sarili niyang bridge ID. Kung sanang if only the bridge ID of S2 is lower, then the root ID to be recognized is the lower one. So since wala, uh, S1's bridge ID is lower than S2's, then S1 will record yung sarili niyang its own bridge ID as its root ID to acknowledge that the lowest so far that S1 encountered is 24,577. So yun yung lowest. Now after that, both of them will send value to uh, S2. Ayan. So even if S3 recognize yung 1111 ni S2, after that uh, after that update coming from, ayan kasi yung kanina 1111. So after that update coming from S1, sending it to S3, so definitely S3 will recognize that the bridge ID of S1 is lower, which is 24577, and it will use now yung root ID niya as 327 as 24577. Okay? So, saan na yun? Ito. Ayan. 24577. And then, of course, after sending it to S22, ayan, all of them will be using the root ID 24577, which recognizes the root ID of the bridge ID of S1. So in that case, so they are all acknowledging that the root bridge winner is S1. So ganun yung nangyari. Medyo ano ba yan? Shortcut ko na. Medyo shortcut ko na kasi I've already explained it to you a while ago. Okay. So any questions? So always remember, ayan, nakabalon na dyan sa taas. Lowest bridge ID becomes the root ID. Okay? So in this case kanina, 24577 is the winner. So siya yung naging root bridge natin. So we also have the extended system ID. If priorities are all set to default, sabi nga dito, lowest MAC address is the determining factor in lowest bridge ID. Nasabi na yan kanina. Okay? So the priority value can be modified to influence root bridge elections. So take note, sabi ko na kanina, the priority value can also be configured. So meron tayong mga configuration na ginagawa. But For you to be more aware of STP, there are actually different types of STP. Usually, ang ginagamit natin is 802.01d kanina. Okay, kanina. Pero later on, we'll be looking at RSTP, di ba? PVST. So we have 802.1d, the original STP standard. And we also have the CST, yung one spanning tree instance, yung CST. We also have PVST Plus. So in-update lang nila si 802.1d para magkaroon ng, kasi dati kasi minsanan na lahat kay 802.1d. So lahat ng VLANs, imagine marami tayong VLANs, magkakaibang grupo 'yon, 'di ba? So there are different groups. Kaya lang in PBST, there are election for each VLAN. So magkakaibang computation na naman. And then we have the 802.1d 2004 update. So in updated bridging and STP standard lang naman yung modification niya. We have the 1W, the RSTP. So nagdagdag ng role, yung kanina nakita niyo naman na yung alternate port. And exchanging BPDU, enhancing BPDU exchange. So we also have the PVST plus. So improvement nung or enhancement nung RSTP. Okay, later, don't worry, there's a separate discussion for each of these items. So we have the multiple VLANs, MSTP, na para magkaroon ng kanya-kanyang or multiple VLANs can have the same STP. STP instance, yes, STP instance. So let's go now to the characteristic. So maybe you are concerned about how resources are being used. So ayan, tingnan nyo na sila. STP low, high for PBST plus, medium for RSTP. Very high for rapid PBST, PBST plus, and medium or high to MSTP. The convergence, yung RSTP, rapid PBST plus, and MSTP ang mabilis, ang fast. So we have yung all VLANs, the improvement is per VLAN. We have the all VLANs for RSTP, the improvement, rapid PBST per VLAN, and then MSTP is per instance naman. So ito lang naman. Siyempre, ang pinag-uusapan natin dito is usually the PBST plus or rapid PBST plus. Okay. So the original 802.1d, so nasabi ko na kanina, let's just look at the items in the presentation. So alam nyo na yung one spanning tree instance for the switch network. Lahat-lahat yan magkakasama. So no load sharing, no uplink must block for all VLANs. One uplink, sorry. Tama yan. One uplink must block for all VLANs. Low CPU utilization because only one instance of STP is used or calculated. Actually, I don't see any more and not much discussion about this kasi very straightforward naman yung mga sinasabi nila. So anyway, this is just an overview. So after improving the 802.1d, so Cisco PBST Plus, so for every VLAN, they can have their own instance for STP, spanning tree. So one port can be blocking for one VLAN and forwarding for another VLAN. So ito parang ganito sa diagram. This port F03 is forwarding port for VLAN 20. At the same time, it's blocking port for VLAN 10. Pwedeng ganon kasi it depends on who will be the winner. In this case, the root bridge for VLAN 10 is this switch and the root bridge for VLAN 20 is this switch, di ba? So, syempre, kung ganun na mangyayari, so malamang makikita nyo na doon pa lang sa distance that the VLAN 20's alternate port or blocking port is somewhere in this area. Okay? So in that case, ito nga yung F02 yung blocking niya. At yung blocking naman ni VLAN 10, somewhere around this area, which is ito, yung F03. Pero forwarding siya ni VLAN at 20. Okay? Dito naman forwarding siya ni VLAN 10. So, kasi nga per VLAN. So, yun yung ano natin, yung difference between 8021D and PVST plus. Okay? Can load balance can stress the CPU if a large number of VLANs are used. Okay, imagine that. So again, port states and PVST operations. So I'll be leaving this to you as reference para alam nyo yung mga operation like can receive or process BPDUs for every port state. So can forward data frames receive on an interface, can forward data frames switch from another interface, can learn MAC address. So sa mga blocking, listening, no. Learning and forwarding, yes. Disabled, syempre lahat yan, no. Okay, yung nakaka-receive ng BPDUs, of course, lahat sila, dinadaanan yan eh. Kailangan ma-receive yan ng bawat switch. So can forward frames receive on an interface? Blocking and listening, of course, no. Kasama pati yung learning. The one that can forward is, of course, yung forwarding port. And then, can forward data frames. Data naman, ganun pa rin. Parehas lang sila. Forwarding yan eh. No, 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 no. Yung blocking, listening, and learning. And then yes sa forwarding. Okay. So we have, balikan natin yung ano kanina. The extended system ID. So usually we have the extended system ID. Ano lang naman yan, you're just adding the VLAN number sa priority to avoid yung yung pagkakapare-pareho. So the VLAN number is added to the priority value. So example VLAN 2, if the priority is 32770, so it's actually 32768 plus 2. Diba? So, kaya naging 32770. So, it can modify the priority number to influence, okay, to influence the root bridge decision process. Again, mamaya, we'll go to the configuration. There's a segment in the presentation that shows the configuration on these priority IDs. Okay, para ma-adjust nga. So there are reasons to select a particular switch as a root bridge kasi especially if you are the one who did the topology. So maybe you can imagine already what the future will give you or what will happen later on in the network. So these are some reasons. Switch is positioned such that most traffic patterns flow towards this particular switch. So kumbaga makikita nyo naman na dun sa diagram pa lang nyo, yun yung strategic na area para maging root bridge. Baka mamaya dali niya dun sa area na to wala namang tao. Kasi there are topologies like that. And maybe because of the numbering of the VLANs, naka-apekto na in-expect nyo na ito yung mananalo dahil yung switch na yun ng nagpo-fall dun sa mababang criteria, then most probably mag-worry kayo and you'll be wanting to adjust the priority ID para manalo yung nakikita nyo na supposed to be a switch in a strategic position. So that time you need to adjust already the priority para naman sila yung manalo. Another is bago yung switch ko. This switch is the newest among the switches that I have and that's a good amount of memory, better processing power, and better CPU. Okay? Then siya yung panalunin mo. And then lastly siguro yun nga, yun yung pinakamadaling i-manage remotely, madaling i-access. Siguro dahil bago na rin, di ba? Maganda yung switch. Then we can consider that this switch is a switch which we can easily access and manage remotely. Sabi nga dito sa presentation. So then, most probably yun na yung reason nyo. Sabi ko nga, you are the one who designed the topology, so you should be the one who can imagine how the future will be in this topology, how the area will be congested later on, how to deal with the network, then change the priority. You're the network administrator. One switch was, let's say, ano ba nangyari? Upgraded? You upgraded another switch, okay, nasira yung switch nyo. You replace it with the new one. Alam mo na bago yung ni-replace at maganda naman yung location niya. Then you adjust, di ba? Adjust accordingly. It's up to you. Okay. So overview of rapid PVST. So it speeds up STPD calculations and converges quicker. So kaya if you're looking at the table a while ago, then that's the reason. So it's a Cisco version of RSTP. So two new port types, yung alternate and blocking port na pinag-usapan natin kanina. And independent instance of RSTP runs for each VLAN. So Cisco features such as uplink fast and backbone fast. So these are not compatible with switches that run RSTP. Okay? So meron tayong anong ganyan. Version na ganon. So BPDUs. So again, I'll leave the diagram for you to have an idea of the different composition of RSTP BPDU. We have two types, yung ano yan, yung version 0 dun sa original and version 2 dun sa bago. So ito lang naman yung difference nila. Yan. So this is the version 2. So these are, sabi nga, alam nyo naman na ang BPDU, di ba? So it's being sent to communicate yung mga parameters nila sa ano. Kaya nga kung mapapansin nyo, going back to the slides, these are the common values we are looking at because of because of them being determining factors for our root bridge. So edge port, pag sinabing edge port, ito yung walang nakakonect na hindi siya interconnection ng mga switches, meaning end devices yung mga nakakonect. Okay? End devices lang yung mga nakakonect. Kaya nga tinawag na edge port. Okay? So, pagka edge port, they immediately goes to forwarding lang yung state nila. So, in this case, kung saan nakakonect yung server dito, yun yung edge port. Ganon din yung mga computer kung saan nakakonect, yung mga port na yun, ang mga edge port na tinatawag natin. Okay, so link types, pagka dalawa kasi, point-to-point or shared. So point-to-point, yun yung interconnection ng mga common switch. Kasi full duplex sila. Okay? Pwedeng magkasabay-sabay. Samantalang pag gumamit ka ng hub, although wala naman nang gumagamit gano'n ng hub ngayon, so yun naman yung shared. Okay? So half duplex lang kasi sila. Parang yung ano yung ginagamit yung radyo. Parang walkie-talkie, 'di ba? Walkie-talkie. Half duplex. Okay, the configuration is very simple actually. So these are some of the Catalyst 2960, but of course we all know that meron pa tayo ibang mga catalyst na pinag-uusapan. So two ways to influence the root bridge selection process. We all know this. Nasabi ko na kanina, yung configuration is just like this. Spanning tree, alam nyo naman na yung gagawin nyo dyan, question mark, di ba? Lalabas lahat. Then spanning tree space, then question mark, every option will be shown to you. So, tawagin nyo na lang yung VLAN na pinag-uusapan nyo or ginagamit nyo. So, for example, since walang nakakonfigure na VLAN, VLAN 1 gamitin nyo. So, spanning tree VLAN 1 root primary. So, automatically, alam nyo na, di ba? Primary na siya eh. Or, pwede nyo rin sabihin na priority is set to babaan nyo, di ba? From the default na napakataas, 30, 32 something, gawin yung gawin yung mas mababa. Okay? Or, yung kabilang switch, pakialaman nyo, gawin nyo siya na secondary. Like spanning tree VLAN 1 root secondary. It will become the secondary, the other one will become the primary. So, yun lang naman. If you are into the port pass and BPDU guard, so ito yung magiging configuration natin. I-enable nyo lang yung BPDU guard and then yung port pass, type nyo lang sa port, yun muna yung port pass. Okay? So ano ba yung port pass? It is port pass is used on ports that have end devices attached. Remember that. Sa forwarding ports lang sila. Okay? So why do you need to do that? There are issues with DHCP later on. Para wala kayong maging problema sa DHCP. Ayun pala, allows DHCP to work properly. And BPDU guard disables a port pass that has port pass configure on it if BPDU is received. Kasi nga, pag later on, di ba, sabi natin, nagkakaroon ng update yung mga switches that is based from BPDU. But there is a BPDU guard. So, kapag naka-enable siya, alam niyo na yung mangyayari. So, sabi nga dito, BPDU guard disables a port. Okay? It disables a port that has port pass. Bakit? Kasi nga, ang port pass is edge na yun. And devices ang nakakonect sa kanila. So, what's the need for the broadcast to pass there? Kung BPDU sila, ang BPDU para lang yan sa mga switch for the updates, di ba? So, i-disable na nila para hindi na dumaan doon. Kasi port pass na nga sila, di considered na end devices na yung nakakonect doon. Hindi na kailangan na sama pa sila sa broadcast. So that is the use of BPDU guard. Kaya nga from the name itself, pangalan pa lang BPDU guard. Okay? So, syempre magkasama lagi yan. Pagka port pass yung end device, pwede mong lagyan ng BPU guard. Okay? Okay. Load balancing. It's more on look at the modification here. Ito. There's a configuration here. Spanning tree mode PVST. Extended system ID VLAN 1 priority setting to 24576 VLAN 10 priority setting to 40 96 and 28672. So looking at the PVST, the spanning tree configuration here, from S3, spanning tree VLAN 20 root primary. Okay? VLAN 20 root primary and VLAN 10 root secondary. So, anong effect nun? So, automatically, kung VLAN 20 primary to, yung kabila will be secondary lang. Okay? And then, kung secondary siya ng VLAN 10, yung kabila ang magiging primary ni VLAN, root bridge ni VLAN 10. So, it's up to you on how you are going to do the configuration. You can also set yung priority, binago niya yung priority para mag-adjust na automatically yung election. So it's paulit-ulit na lang kanila ever since the first configuration. Okay, the spanning tree mode. You just need to specify the or enable the protocol. So in this case, spanning tree mode, our PVST ba or rapid PVST? Spanning tree extend, system ID, ayun, VLAN 1 priority 2, 4, 5, 7, 6. Nag-set na naman sila. Kagaya ng ginagawa natin kanina. Ayun, paulit-ulit dito. The setting, it's just specifying the mode. Lagay nyo na lang, spanning tree mode, question mark, space question mark. And then you can see already the different modes available. So, okay, if you are into the PVST, rapid PVST, okay, so ilagay nyo lang spanning tree mode, rapid PVST. These are just configuration. Once you put the mode already, then makikita nyo na sila. So I think before these are the last part of the discussion already, but it's more on an analyzing lang naman kasi. So I have another activity for you later on where you can focus more on the configuration of every uh, modes that we have. So of course, we have the packet tracer activity later on din na gagawin. So yun lang naman. So I think everything is done now. It's discussed already. So if you have questions, just inform me. I'll be posting this video para may copy kayo. You can comment in the comment section too if you want to para masagot ko later on. If you need a new tutorial, just post there para magawan ko ng paraan. So kung walang tanong, I think we're done. Thank you very much.